We have a region bounded by these graphs, and we want to take this bounded region and revolve it about the y-axis and then find the volume of the solid of revolution. So this is the graph for y equal to the square root of x. This is the line y equal to 0. This is the vertical line x equal to 4. And this is the axis of revolution, which is the y-axis or the line x equal to 0. Since the axis of revolution is vertical, this vertical line x equal to 0, we will fill our bounded region with horizontal rectangles. And then if we revolve each rectangle around the y-axis, then we get a disk. And we want to find the volume of each disk and then add the volumes of the disk together to get the volume of the solid of revolution. And notice that when we revolve this disk, the disk corresponding to this rectangle right here around the y-axis, we got a hole in the middle. Since we have a hole in the middle, we will use what's called the washer method to find the volume of the solid of revolution. So this is what this disk right here, this is what it looks like. So you would have an outer radius and an inner radius for the hole. And since the rectangles are horizontal, to get the volume of the solid of revolution, we'll be integrating with respect to y. And since we're integrating with respect to y, what we need to do is rewrite this equation, the equation y equal to the square root of x, so that x is a function of y. And so here's y equal to the square root of x. Now we square both sides, so we get y squared, the square root of x squared, and then the square root of x squared is just x, and then we get x equal to the x is equal to y squared. And so the outer radius, which is the distance from the axis of revolution to the line x equal to 4. And so to get this, get the outer radius, we'll do 4 minus 0. So 4 minus 0, and we get 4. The inner radius is the distance from the axis of revolution, which is the line x equal to 0, to the graph. But the graph is x equal to y squared. And so the inner radius will be y squared minus 0. This is the line x equal to 0. The graph is the graph of x equal to y squared. And so the distance of the inner radius will be x squared minus 0. It'd be y squared minus 0. And so that's why y squared minus 0 is just y squared. And again, to get the volume of the solid that we want, we'll find the volume of the entire solid minus the volume of the whole. And then notice that for this particular graph, y ranges from 0 up to 2, because this point is the point 4, 2. So y will go from 0 to 2. And therefore our limits of integration will run from 0 to 2. And the volume of the entire solid, for the volume of the entire solid, we'll use the outer radius, which was 4, and so we get 4 squared. And then the volume for the inner radius was y squared, and then we squared it. And so 4 squared is 16, and then y squared is y to the 4th. Antiderivative of the constant 16 is just 16y. Antiderivative for y to the 4th is just y to the 5th, dividing by 5. And we'll evaluate from 0 to 2. So we put a 2 here, we'll get 32. And if we put 2 here, we'll get 2 to the 5th, which is 32, dividing by 5. And we'll end up with 132 minus 32 fifths is 128 over pi over 5, and then times pi. And so the volume of the solid of revolution is 128 over 5 times pi.